Hello, everyone. Yes, I'm between you and the quiz, and between you and drinks, so it's a hard one. I have to say I'm really proud that the organizing committee allowed me to do this. I'm also very proud that they are so innovative because the talk earlier about autism in the tech industry, really important. And this one. So the subjects that you see here, I mean, you get down into the details of the XML file that tells you where the key is, or BGP, BCP38, and I missed a few other talks. But at the same time, you have this wider view of things, so that's really great. I do have a confession to make. This story has a little bit more I in it than I would normally have. Now that I've told you about it, you're going to be very sensitive to it. Hopefully, I'm fair. I don't name anyone else, so I'm not throwing things at anyone anonymously. But I do think I was part of the story, so maybe I'm allowed to do a little I. Anyway, again, thank you very much for having me here. I was going to call it the origin story, and when I looked that up, it said, you could call it the Pourquoi story, the French thingy. And the thing about the Pourquoi story is it says about mythology. And I'm like, yeah, there are definitely many myths in here. I don't mean myths like, mythology from thousands of years ago. Myths that are just not true, but I can say them, and you'll find it hard to contradict. The problem with me is I'll contradict them myself, but you'll see that. Okay, so let's get going. When I joined, before I joined Juniper, this is a story of history. I look around and see several young people who weren't even born when I started working at Juniper. So, à peu près. So, I started off in file systems. I was at a small company called ACSC, and there I worked on a file system called Unitary. And Unitary is this file system that basically very hierarchical. And the lowest level of the hierarchy was robotic tapes. So you'd have a caching system, you'd have maybe something in memory, you'd have something on disk, and then you could have a couple of other layers, and the bottom was a robotic tape. And if the file that you weren't looking for was there, you'd get the robotic tape to pull it out, and hopefully it was there. So, file system guy. At SGI, I worked on something called XLV, which is part of the XFS file system. So that was a really nice project. Even better, I joined NetApp, and NetApp had this homegrown system called Waffle, built on their homegrown microkernel. Really exciting stuff. Waffle was so well optimized for NFS. I had a great time there. But I only worked there a year. Then someone in NetApp said, why don't you go check out this little company called Juniper? So I said, okay, fine. Let me go see what they have to say. Went and talked, did an interview. I had no background in networking, no background in chip making, because chip making was a big part of it. But they said, yeah, you seem like an okay guy. Why don't you come on board? So when I did come on board, I was reporting to Paul Traynor. I don't know how many of you know Paul Traynor. So he was sort of informally the lead of the software group. And he looks at me and he says, what do you want to do? And I say, I want to do routing protocols. I've just come to a networking company. And he says, yeah, that's a good answer, but you don't have any background. So let me put you in something that we need and that you seem to have knowledge about. Work on the device drivers for our interfaces. We're doing them in a very different way. The base code was FreeBSD. So it says, why don't you work on configuring device drivers? So for those of you who know some Junos, we have these notions of an IFD, an interface, the device, the physical interface, an IFL, a logical interface, an IFF, an interface family, IFA, the addresses, and then next hops and routes. So I said, we need to configure these. Typically, in FreeBSD in those days, you didn't have the notion of IFLs. So basically, they said, go work on this. So I said, OK, it's a place to start. I get to know the system. The first day I show up, and there's a picture of a hammer and a screwdriver there on purpose. I mean, it sort of means that I was working on the infrastructure. But literally, the first day I show up, it takes me to this room. There's a table. There's 7 or 8 desktop PCs on it. There's 8 Ethernet PCI cards. You guys don't know what that is, but there were such things. And he says, we need to put one of those in each of these. And I said, what? We're going to build a small network here. The only network we can build is Ethernet. And of course, these don't even talk about wireless. They don't even have physical Ethernet until you put them in the PCI cards. So that was my first task. I said, whoa, where did I end up? So the point for me was I had to learn from scratch. What is PPP? What is Cisco SDLC? Where does this fit into this whole thing? Oh, so you have a packet, you have a header, you have the body of the packet, you have overhead that may not even be part of the packet. You have these things called keep alives. So I had to write the drivers for PPP, Cisco SDLC, configuration pieces, figure out how hellos work. For frame relay, there's the ANSI standard, and there's Gang of 4. I don't know how many of you know Gang of 4. It's like, keep that a secret. So, I learned a lot of stuff down there in the bowels of the machine, understanding how these device drivers need to work, because this is how the protocols, the layer 2 protocols, work. Frame relay and ATM added sub-interfaces, real sub-interfaces. And then I moved on to doing route tables and next hops. As I said, what I really wanted to do was work on routing protocols. The next task I got into the routing protocol space. We had a big customer, UUNet, who's today part of Verizon, AS701, 702, not in Europe, yes, 701 in the US. So they were very eager to use our stuff, but they said, hey, we need traffic engineering. So we were focused on building IP-based routing, and Paul Traina and Tony Lee were pushing for MPLS, and then this became a really good reason to do it. If we do MPLS, we can do traffic engineering. Basically, Mike Odell said, we need to be able to do things like tell the router, I want to connect A to B, here are my constraints, make it so, right? So we said, OK, we'll do that. To do that, we had to have TE requirements, and then what does it mean? What are the type of constraints you have? And then we needed extensions in ISIS, which Tony worked on. We needed to implement RSVP-TE, which a guy called Durwa Gan worked on. And then we needed a traffic engineering database where everything from ISIS was put. And then we needed an algorithm that would compute paths across networks, satisfying these constraints. And that's what I worked on, the CSPF piece. And then we had to have this all work together, because initially, when you create an RSVP-T LSP, you said, here are all the hops you go through. Then we said, OK, you create the RSVP-T LSP, you say that the hops will be computed by CSPF. You give the constraints. CSPF does the computation and brings it back here. So the second big project I worked on was traffic engineering. I mean, I had a piece of it, right? And this was my first exposure to the routing protocol daemon code. I'm going to skip this. I'll come back to that. So we're going to go on a memory ride. Back in the mid or late 1990s, the internet was coming up, but service providers were primarily building voice networks. And then they were making the voice networks bigger and bigger. And they said, how do we do this? We can just use SONET and we'll, or SDH, and we'll channelize it down to DS zeros, and everyone will have voice. And someone said, but there's this thing called IP. There's this packet-based stuff that's sort of getting interesting. Like, we'll find some way. So there's this big challenge of how do I build a network, the core of my network, which will carry packets as well as bits. And so they said, some people said, just do it over SONET, packet over SONET. And some people said, no, you got to do it over ATM. ATM gives you really good quas. ATM gives you traffic engineering. ATM lets you do multiple things. That's the way to do it. So UUNet bought into that, and they built an ATM-based network because, again, they were very much into traffic engineering. And when they started looking at all that, they said, OK, there is traffic engineering, yes, but what we really want to carry is IP, and IP over ATM really sucks. The n-squared problem of trying to create adjacencies here was one. The 40-byte packet, which is a very common packet size in IP, became 2 ATM cells because of AL5. There were all kinds of silly problems. ATM had its own protocols, which didn't at all work with IP. So they said, we need an alternative. So they started looking at this thing. What if I had an infrastructure that would carry anything? And so we'll just do packet over SONET. But I will impose onto this traffic engineering. On the edge, my customers still come to me and say, I want frame relay, I want ATM, I have a PBX that needs ATM connections. And I'll say, yeah, bring whatever you want, but my core is going to be packet-oriented. How do you do this? And by the way, this was a separate fight. Do I build an ATM core, or do I build a SONET, a packet over SONET core, right? At this point, IP was just coming and MPLS was not really in the picture. But if you want to come down to this picture, you had to bring traffic engineering here, and you had to bring the ability to carry all these different media. So if I have PPP, frame relay, or even Ethernet, which was coming up as something you might want to use across the WAN. So that's where people said, can we have a technology that excuse me, take any other layer 2 technology and put it over my core? So can I build one core that will carry everything? And they said, this is what MPLS was for. MPLS, the MP is multi-protocol. And typically you think of it as multi-protocol at the time over whatever. So I can carry it over PPP, I can carry it over Ethernet, I can carry it over ATM. But it's actually multi-protocol above as well, where you can say, I can carry anything over this. But we had to prove that. So the question that came to me is, can you carry PPP over an MPLS network? Can you carry ATM over an MPLS network? Can you generalize this and carry any layer 2 and cap over this? So I said, yeah, this should be possible. I had to do some more reading, consult with other people who knew the stuff, Tony. And I said, yeah, we should be able to do this. We also invented something called translational cross-connect that said, if the layer 3 is specifically IP, whether it comes in on PPP here and wants to go out on frame relay there, can you do this? It's like, yeah, we'll just extract the IP part and put it here. In the middle will be whatever we need, some MPLS thing. So basically, I had worked on layer 2 and caps and had to really understand layer 2 and caps. I had to work on traffic engineering. And then I was given this task of running layer 2 over an MPLS network. This is a part of the myth that this was not something that was meant to be. It just happened, right? But I was in a unique place where I could implement this stuff. I knew RSVP TE from the inside. I knew TE from the inside. I knew layer 2 protocols or layer 2 encapsulations better than someone who might have come in with a networking background. I came in with nothing, so I had to learn everything. So I was given the CCC project. And I did everything in the CCC project, from the CLI, the Juno CLI that will allow you to create a connection, down to interacting with RPD, interacting with DCD, which is the device control daemon, going to the kernel, going to the microkernel, down to the chip. So we had these chips. It was very ingeniously named A, B, C, D. And the B chip was the input-output chip. And so it had a BI component and a BO component. And BI microcode would parse incoming packets, and BO,
Sorry, could you say that again?
BO microcode. That's, if Siri had been around then, she'd have told me exactly how to write all this. So the BO microcode would write the output, the rewrites for the packet. So this was done. At that time, we were working from work. We had just come to work. But I just wanted this focus time. So I worked from home, and nothing to do with COVID. Just worked from home. I wanted to focus on this. I would work from 8 p.m. to 5 a.m. This is a part of another myth, because when I asked my wife about this, she says, what? In theory, I'm working from 8 p.m. to 5 a.m., writing code, 1 ear open for the baby. If the baby cries, go give her milk or change the diapers or whatever, then go back to work. She said, yeah, you might have done that twice. But like I said, nobody can prove or disprove this. What was really cool, though, is back then, I was actually a useful member of humanity. Today, I don't know. But got this project done. And that helped a lot. And this project was almost immediately deployed. People wanted this. But as we got into that, we saw that there were some issues here. If I really want to use layer 2 over MPLS, if I want to do it with CCC, I have the issue that if I have n endpoints to connect, I need n squared connections. And all of these connections are done manually. And that's a pain and prone to error. If I do create these connections, nothing in the connection says the connection from A to B and the connection from C to D belong to the same customer. They're related. And if one of them doesn't work, the customer might not be happy. So they're just independent connections. And it's like, okay, that's fine. But it's not fine if you're saying they're all connections for one customer. The last thing is you can create any topology you want, but you're doing it manually. So again, you're trying to create a dual hub and spoke topology, and you miss something, you've messed it up. Or you're trying to create a full mesh, and you've missed one connection, and it's not a full mesh. And those things are really hard to debug, because mostly it's working, but one guy can't talk to one guy. So one solution was, let's do this single-sided provisioning. In other words, I want to create a connection from A to B. The way that works today, the way that it worked in the beginning, is you create an RSVP LSP from A to B and from B to A, and then you create a connection from A to B saying, take this input interface and stitch it into this RSVP LSP. You go to B and you say, I need you to do the same at that end. And when you're done, you've connected this ATM interface on the edge to this RSVP LSP in the core. Yeah, it helps a little, but you got an n squared problem and you divide it by a factor of 2. Not enough, not really enough. And you still have the problem that you're not really connecting all these together with one unifying concept. So I said, okay, let's go to a different mode. Let's use this technology called BGP layer 3 VPNs. I used 2547 there because that's where my mind was at. Now it's 4364. But basically, this had a completely different approach. It said, you've got N endpoints. You go to one of them and say, you are a part of this VPN. Go find your friends and make all the connections you need. You go to the second one and say, oh, you're also part of this VPN. Go find your friends, and so on and so on. So to configure N endpoints in a VPN, you configure N independent things. There's no N squared, there's no, I need to do these two together in one shot. They're just independent. And that was a really, really cool idea. And I said, that's exactly what I need to be able to create my layer 2 VPN. Plus, this whole thing will be called one VPN. Back in the day, we'd call these VRFs. And so we'd say, this is a VRF for Acme Corporation. Now you'd say, this is a layer 2 VRF or layer 2 VPN for Acme Corporation. So you have a notion of all these things that are going to come up belong to one customer. If any one of them goes wrong, that customer is the one that's going to see some trouble. So there's that relationship, that idea that you have related connections is embedded in the concept of doing it as a VPN. And the last thing is you get this unified approach to making VPNs. So however you build your layer 2 VPNs, your layer 3 VPNs, VPLS, if you use similar concepts, then you train your staff accordingly. You build a set of rules of how you make them, how you build them, how you manage them, how you debug them. And so many of the concepts can be shared, so it actually becomes much easier. But if you do your layer 3 VPNs using BGP and your layer 2 VPNs using LDP, and then you maybe you use some auto discovery, which by the way never actually got deployed. It's completely different, and it's not, you get no leverage in your operations. Yeah, so one of the things that happens in this is, in BGP, BGP layer 3 VPNs, when I advertise that I have a route or even an endpoint for a VPN in some layer 3 VPN, I hand you one label, and everyone uses that label to talk to me, and I know who to send it to. That's how layer 3 works. In layer 2, I have to hand you N-1 labels because there are so many circuits behind me, and I need to know which circuit to put this traffic on. So I can't just say, here's one label. I have to give you a set of labels. So I came up with this idea of a label block. So I've got 10 connections behind me, 10 VCIs, or 10 VLANs. I'm going to send out a block of 10 labels. So one advertisement, 10 labels, and I'll give you a way to know which label to use for which of these VCIs. So that was a concept of a label block. I need different topologies. I need full mesh, I need hub and spoke, I need dual hub and spoke. Well, this was solved by 2547 by using route targets. So I said, oh, I'll just use that technology. Okay, this is all going very well. Should we standardize this? This is when the roof fell on my head. And there was absolute opposition to standardizing this. So fine, we made it an informational document, which basically means here's some information, you don't need to read it. That's an IETF informational document means, yeah, just leave it there. If there's a standard stack, you need to really dig into it, figure out how to implement it, figure out how to do stuff with it. Then people said, okay, that's all good, and yes, there's a point-to-point layer 2 circuits were nice, but we want VPLS, we want transparent LAN service. So again, people said, oh, you can signal that with LDP, but here people really understood that I can't just make them point by point, pair by pair. A transparent LAN service is N things working together as a LAN. I came back and said, I can do this with a BGP. I have discovery. I have the notion of a single VPN. All of these fit together. We have the topology that you need, full mesh. So finally, they said, okay, that one we will standardize. So BGP VPLS was the first one that was standardized as, okay, we need this, it makes sense to do it, but I couldn't even put a normative reference to the BGP L2VPN because that was informational. So the way references work, you can only put a normative reference from a standards track document to a standards track document. So it had to be an informative reference. But maybe someone read that at that point. So, of course, there were a bunch of people saying, nah, this is really bad, you shouldn't do this. The biggest complaint was, BGP is for layer 3 information. You can't use BGP for layer 2. Actually, the truth is, there was no layer 2 information across this signaling, except what is the type of layer 2. There was configuration information. There's something that said there are 10 circuits there that need connection. There was information about what are the endpoints. There's the route targets that will create the topology. But there's no actual MAC addresses, VCIs, VLANs, nothing. Today, we have MAC addresses in their full glory in EVPN, carried over BGP. So somehow today it's okay. We also have layer 4 information that came later, BGP flow spec. So the idea that BGP should only be used for layer 3 and should only carry IP addresses is something that was, it was true at the time, but we had multi-protocol BGP, but that was used as a stick to say, no, stay where you are, don't come out of your hole. One real problem was you couldn't do per connection QoS, but actually in the end, not that many people needed it. Another was BGP is too complicated. This is one of those scary things where they try to scare you into not using a technology, and it worked. And then it's the same old arguments repeated. It is actually a bit of a stretch to try to use BGP for layer 2. The funny thing is, I can tell you this now, I could have told you this back then. None of the people who are arguing against BGP brought this up. Layer 2. Layer 2 is source destination oriented or circuit oriented. Layer 3 is, I don't care where you came from, you arrived here, I look at your destination and I'll send you on. I don't need to keep any sense of where you came from. Whereas for layer 2 stuff, you do need to know where it came from. So that is what led to having label blocks and so on. It's primarily a data plane problem, but there is some aspect in the control plane that's needed. So, but here is something that someone could have said, hey, there's a bit of a mismatch. No one did, and now we don't care because we're using this in EVPN. So what that left the world with is I could use LDP, and I'm leaving out things like L2TP, L2TP V3. So I can use LDP to create this connection across my network, tell each PE out of band who he should connect to for the connection. I can use LDP for peer-to-peer signaling and BGP for auto-discovery. I think that was a pretty complex solution, but in the end, it was never really deployed. Or I can use BGP for the whole thing. And if I did that, then I'd have to use label blocks and a few other things. But that was a solution that a few people did converge on. AT&T in particular really liked the idea of using BGP for L2VPNs and VPLS. Well, from here, people went on to things like BGP auto-discovery, which I just mentioned. So they call this VPWS. BGP VPWS was auto-discovery and signaling. So even though this was an informational document, people said, well, now that people are deploying BGP for layer 2 stuff, why don't we do it for our even our point-to-point VPNs? So the same technology was used for VPLS. BGP auto-discovery and signaling is used for EVPN. But here, you're actually carrying IP addresses and MAC addresses in the control plane. So it's no longer that BGP is carrying control information, and the data plane does its own thing by doing MAC learning. You actually carry the addresses in BGP. So much for BGP must not be used for carrying layer 2. So people ask me, do you feel vindicated? And it's like, no, it's the wrong question, right? It's the nature of how we have discussions in, technical discussions, primarily in standards bodies, but I mean, you could have them offline as well. You want diversity in thinking. You want people coming up with crazy new ideas. And then you want to have a technical discussion of, is this going to work or not? And to do that, you have to be able to prototype and say, yeah, this actually could work, or wait, there are these issues, and then maybe you solve the issues, maybe not. And then you want to compare that with another solution as much as you can, apples to apples. But dogmatic adherence to your ideas, and maybe that adherence comes because it's my company or some political reason. Someone earlier was talking about the layer 8 and layer 9 of the network. Those are not good reasons for doing this. So the industry wasted effort, they wasted time, and they'll do it again, and they're doing it right now. At a conference, just as a side story, a speaker who was peddling the idea of Rosen-style multicast VPNs, layer 3 VPNs, they at the time wanted to carry customer multicast addresses in PIM, not in BGP. So the theory was PIM was meant to carry multicast routes. BGP was not. So he made this blanket statement that BGP was not meant to do this. Yakov Rector comes up to the mic. You can see this guy trembling. This is the speaker. And Yakov Rector says, do you know what BGP was invented for? What was it designed for? No. BGP was meant to carry 4,000 IPv4 classful addresses. That was it. That's the first 3-napkin diagram. Okay. Since then, we've added classless, CIDR. We've added multi-protocol. We've added V6. We've added VRFs. We've added a whole bunch of things. Who are you to talk about what BGP was designed for and not? And that guy just, right? But next conference, same presentation. Like, why are we here? What's the point? So I'm only going to explain one of all these pictures that I've added to my presentation. Who recognizes this picture here? The painting. Oh my God. It's by Van Gogh. It's called Angelus. It's actually a copy of Millet's Angelus. And it's basically two farmers at the end of the day pausing to say, thank you for the day. I'm not religious. I'm not about to become religious. But I think we need more of this. That you just, at the end of the day, you step back and say, it was a good day. Not every day, but it was a good day. I'm here, I'm alive. We'll go on tomorrow. But yeah, we don't do that. We just do stupid things, we repeat them, and then we come back with bigger guns. What's next? So the chapter on layer 2 VPNs is coming to a close. Actually, most of layer 2s are going away. In many networks, they only have Ethernet. And so the only layer 2 technology, even on the customer side, is Ethernet. So the focus is on EVPN, which is BGP-based, so there's no fight there. But in general, there's a clear move to IP. So, I think we will have EVPN for a while. In fact, we'll have layer 2 VPN of different kinds for a while too. Once things are in the ground, they stay in the ground for a while. VPNs themselves are changing. So a lot of people are now talking about do-it-yourself VPNs, AKA SD-WAN. MPLS is changing, not always for the better. I'll leave it at that. Much more is being done with BGP. I think it's a good thing. BGP LS, I am a little ambiguous about, but BGP flow spec and BGP EVPN, BGP for anything you want. There's this idea that you carry JSON over BGP. Yeah, sure. Why not? But in general, this chapter is kind of coming to an end. And I have moved on. I'm now working in the management plane. So if you think about what's happening in the router, you have a data plane, a control plane, and a management plane. Well, the management plane is also, the Uber thing, the SDN layer, the whatever you want to call it. And I used to be very much against that. But I can see the value, and I know that there's some things that are better done centrally, and there's still many things that should be done in a distributed fashion. So one of the things that I'd written somewhere, but I forgot to say is, or maybe it's in the next slide, yeah. When you have these kinds of situations, when you're really passionate about something, which is good, passion is important, but then you get all this pushback and you get these people telling you different things, you need to know who you can trust from the point of view of, is this technology good? Is this idea good? Are we going in the right direction? You need to do your homework. Have I looked at all the aspects of the problem? Have I prototyped whatever bits I could prototype of the problem? At some level, you just need to trust your own instinct. And this is, again, where your teachers and your homework builds up your confidence that you are on the right track. You do have to be stubborn. There is an aspect of this that you have to stick to your guns, but you have to listen. And I will say that there's some very smart guys I've talked to who just can't listen. In a way, the more strident they're shouting, the more you should say, I must have something good here, otherwise they wouldn't be fighting so much, which is a bit negative, or I don't know. And then, once done, move on. I mean, you may have a little more things to do there, but get it done, move on, leave all the emotions behind, get to your next thing, because there's a lot more stuff. Very easy to say, very hard to do in the spur of the moment. You've also invested so much in it, but it's very important for your own psychological health. I'll leave you with this. This is a patent that was filed, we applied for in 2001. It issued in 2006. It is now expired, so feel free to implement. We never asked anyone for money on this. You will see some keywords here. Virtual network, local intervention, which is basically I'm going to provision each device by itself, not in pairs, not the whole thing together, but each device by itself. Label base and label range, which is needed for the label block stuff. Yeah, so that was it.
Maybe you have an opportunity to answer one or two questions, if there are any.
Out of time.
We do. Well.
Okay, I will.
Okay. Well, then let's
tired.
pose them. Come on. Who has a question for Mr. Kompella? I do find it interesting myself that on this day, where on a typical day there are about 3 companies calling our office asking us to implement an EVPN VXLAN network. But on this NLNOG day, the 2 longest presentations were about MPLS. It's interesting.
Yes.
Ben, you have a question for Mr. Kompella.
Mostly in jest, but you mentioned a whole bunch of interesting address families over the course of the time. What do you think's next? What could you mentioned JSON? I think that would be a great addition. Why not just provision signaling? DHCP. I reckon there's some interesting innovation that can be done here.
So the mention was in jest. The original request when I heard about it was not in jest, but the people who repeated to me were also joking. So I don't expect that to happen right away, but I think the idea that BGP is a protocol that allows you to distribute information. Today we mostly use it for routing, but then we could use it for the link state. We can use it for flow spec. I mean, for flow spec, it's really interesting. I'm not going to send you a route, but I'm going to send you a filter that you can apply so that traffic doesn't get into the network. Right. So if you find things that you can use BGP for in the places that BGP is deployed, I think BGP is general enough to do that. I think we have to be very careful that if you break BGP, you break a lot of things. So one thing that you might do is to say, I'll clone BGP, run it on a different port, not 170, but whatever the next port is. And say, but I'll use the same mechanisms. And I think that would be a very powerful thing. And that would be a way to play with BGP. And then you could do things, back in the day, we talked about exchanging information between providers on what the cost of carrying certain traffic across my network would be, or for a certain latency or whatever. Brokerage, right? Bandwidth brokerage. You could use BGP for that. But you don't want to use BGP for that. You could say, I have a protocol that scales nicely, that is very general purpose. I think that idea that what you want, these are the characteristics, these are my requirements, and what the protocol offers, if they don't match well and then you try to hammer it in, that's not great. Yeah. But when it does match well, yes, do it. But the JSON was tongue-in-cheek.
I mean, the cat's out the bag the moment FlowSpec was mentioned, right? Because it's not really a route at all anymore.
Should I expect a draft from you?
Don't dare me.
Mr. Van Pelt.
So sorry that the talk went long. Let it go. Thanks for the talk. This was great. I work on VPP. I use Bird. It doesn't do LDP. Can I call you sometime to get BGP signaling done in VPP? That'd be pretty great.
Cool.
Great. Thanks.
Yeah.
Kireeti Kompella, everyone. Thank you.